All right, the triangle midsegment theorem. So it says find the midpoint of xy and the midpoint of zy. All right. So remember, midpoint is x plus x divided by 2 and y plus y divided by 2. You're just finding the average of the two. Okay. So x is -3, 2. Y is 5, 1. Good thing to label these. And z is also -3, but -2. All right. So to find the midpoint of xy, we're going to take -3 plus 5 divided by 2. And then we're going to take the y's. 2 plus 1 divided by 2. So 5 minus 3 is 2, and 2 divided by 2 is 1. And 2 plus 1 is 3, divided by 2 is, well, 3 halves, or 1.5. So the midpoint is going to be at 1 and 1.5, which looks to be right about there. All right. And then zy, we're going to do -3 plus 5 over 2, which we already know what that is because it's the same thing. This time, though, we have -2 plus 1 over 2. So we already know this is 1 because it's the same problem. And 1 minus 2 is -1, so this is going to be -1/2. So if we go to 1, -1/2, that is right there. All right. In triangle JKL, all right, let's get this down a little bit here. So JKL, this is JKL, it's this larger triangle right here, the blue one. Show that the midsegment MN is parallel to JL, and that MN is 1/2 of JL. Okay, so midsegment is just a line that connects the midpoints. All right, so M and N are midpoints. M is the midpoint of JK, and N is the midpoint of KL, just like we just did. Okay, so like if we would have connected these two, that's a midsegment. All right, so a few things to do here. First off, we need to show they're parallel, so we need to do the slope. Now, again, normally, if this wasn't on a graph, we would have to do y minus y over x minus x on both of these. But we don't have to do that here because it's on a graph, so we can just count. So the slope of MN is, from M, we're going to N, down 1, so down 1, negative, right 1, 2, 3, 4. That's positive. And the slope of JL is down 1, down 2, so down 2, negative, right 1, 2, 3, 4, 5, 6, 7, 8, which reduces to -1/4. So we've proven that these two lines are parallel. So I'm going to mark them parallel, little triangles. Now we need to do the distance of both of them. So we're going to do the distance of MN. So remember, that's the square root of x minus x squared plus y minus y squared. Okay? So we're going to put all this in first, so you don't have any errors with negatives. And let's look at MN. Okay? So M is at -4, 1, 2, 3. So let's write that in. -4, 3. And N is at 0, 2. All right? So we're going to do x's first. -4 minus 0, that's easy. -4 minus 0, no change. And 3 minus 2. So that's going to give me negative 4 squared. Remember, there's going to be a positive number no matter what your calculator tells you. Okay? Plus 3 minus 2 is 1. So 1 squared. So that's going to be 16 plus 1, which is the square root of 17. Okay? Now we're going to do JL. Hopefully it ends up being double this, because that's what we're supposed to prove. So again, whoops. We're going to do JL. Put everything in here first, so no mistakes with negatives. And we're going to do negative 6 minus 2. And the y's, 1 minus negative 1. Here's where we want to be careful, and that's why we do it this way. That's going to be 1 plus 1. Okay? So we're going to get here negative 6 minus 2, that's negative 8 squared, plus 1 plus 1 is 2 squared. So that's going to be the square root of 64 plus 4 is 68. Now, we can't compare radicals because we can't say, oh, 17 should be 34 because we're doing square root. So we need to find out what these are as decimals. So I put it in the calculator already for you. Square root of 17 is 4.12, and 68 is 8.24, technically 825, okay? But let's just go around to the tenths place. So 4.1 and 8.2. So we've proven that the midsegment MN is half of JL, and they're parallel. So what is the midsegment theorem? It says that if you have a line that connects midpoints, then we're going to have parallel lines, and this piece will always be half of this piece. And this piece will always be double this piece. All right, you can just go ahead and put a big old X on that. We're going to skip it. It's just very theoretical and abstract. Basically what you would do is you'd prove that these two are parallel, which obviously they are because they have a slope of 0. And then you would find the measurement of this one and the measurement of this one, like we already did, and prove that it's half. All right, triangles used for strength in roof trusses. In the diagram, UV and VW are midsegments of RST. Okay, so we have a midsegment here, okay, and a midsegment here. Find UV and RS. All right, well, if UV is a midsegment, that means it is parallel to this piece right here, and it's also going to be half of whatever that is. So since RT is 90, that means UV is 45. All right, I'm going to change colors here. And if VW is a midsegment, that means it is parallel to SR, and it is half of SR. So if VW is 57, then times 2, we get 104. All right, so this one we did times 2, and this one we did divide by 2, because we're going from the bigger to the smaller. So you just got to pay attention to which way you're going. All right, in the kaleidoscope, AE is parallel to BE. So let's try to find a color that will work here. AE is congruent to BE. AD is congruent to CD. Show that CB is parallel to DE. Well, what is happening here is if those are both equal, that means this is a midpoint and this is a midpoint. So D and E are midpoints, right? Therefore, this segment right here is parallel to CB. Exit ticket. Let's see if we can get this a little smaller. Pear Street intersects Cherry Street and Peach Street at their midpoints. Okay, so that means this, this right here is a mid-segment. You leave your home and jog down Cherry Street to Plum Street, over Plum Street to Peach Street, up Peach Street to Pear Street, over Pear Street to Cherry Street, and then back up Cherry Street. About how many miles did you jog? Wow. We're going to do this one since we skipped one of the examples. So if that's a mid-segment, Pear Street, it's half of this. So that means this is 0.7. All right? And we know Cherry Street, if this is a midpoint here, right here, that means this is also 1.3, which means this is 2.6. So now we have all the numbers, all right? So let's see what the path was. It says you leave your home and jog down Cherry Street to Plum Street. So we're starting up here at our home. So it says we're going down Cherry Street to Plum Street. That's 2.6. And then we take Plum Street like so. So that's plus 1.4. Then it says we take Peach Street. So you leave your home and jog down Cherry Street to Plum Street, over Plum to Peach, up to Pear. So we're only going here. So we need to know what this is. So half of this is actually 1.125. Then it says over Pear Street to Cherry Street, so that's plus 0.7. And then back home to your house, back this way, so that's another 1.3. So that ends up being about 7 miles. And that's it.